Now, in this video, we are going to take up one more problem on the projections of points to find the shortest distance in the third quadrant. How to analyze this problem? The problem reads as a point capital G is 25 mm below HP and is situated in the third quadrant. Your shortest distance from the intersection of XY and X1Y1 is 45 mm. Draw the projections and find its distance from VP. So to do that, first we're going to take up the problem in the third quadrant. You can see here, this is the vertical plane and this is the horizontal plane and this is the left profile plane. So this is the case wherein the point G is below HP. So when you look from the front view, so here when you look from the front view, you can take this as the front view, and when you look from the front view, you can see that the distance below HP. So below HP distance, as we see from the front view, which is the perpendicular to the plane, the distance is visible in the vertical plane. Similarly, as we look from the top view, we can see the distance in front of VP, but this in front of VP we cannot show that because he has not given the distance. But instead he has given the intersection of XY and X1Y1 is 45 mm. So that means the intersection of XY is this line and the X1Y1 line is this, and this is the line which we are talking about. From here it is 45 mm, it is the shortest distance, so that means from here to here, so this is the distance which is 45 mm, which he has given. So when you look from the left side view, I can see the distance here from here to here. So what I can do is, so when you look from the left side view, I can see the distance below HP, which is 25 mm, and that below HP is also seen here in the front view. So as we took these two together, both will going to lie on the same line. So what I can do is from here, you take 45 mm and cut an arc on this, because we know that this is in front, this is behind VP and this is below HP. So this will going to form the right angle triangle. So this distance is going to be the right angle triangle. As I see from the left side view, you can see this is LSV and that image will going to fall on this. Now once you get this, so then what happens? Obviously we can draw a vertical projector from here and then you draw a horizontal projector. Both will going to intersect at this point. So now ultimately we can be able to get this point, which is L will be equal to what is the distance. Again, that distance which you can see as we look from the top view here. Once you take this, so you will be able to see that particular distance from here to here. So this is how you will be able to analyze this problem. And here, as he has not given any distance with respect to the profile plane, so you can take this particular line to anywhere in this particular block. So this is how you will be able to analyze this problem. But when you go to the step 2, so that means what I am doing is I am cutting at this particular line and then rotating this in this direction, okay, that is to the top. I can take this, and also I want to rotate it in the side view in this particular direction. So once you do that, so what happens? LPP will going to come to the left side, VP is always fixed. So this line, this plane is always fixed. So which is the one which is always vertical here. That is what I am going to show. So once you do that, so HP is the one which is rotated to the top, so HP will going to come here. So now correspondingly what happens to the image is also being get rotated, so that is L will be equal to here and 25 mm will be vertical here. As we see from here, the left side view, you can see the distance below HP, that is vertical here, and when it is rotated by 90 degrees, then what happens to this line? That line will going to become this line here, so which becomes horizontal. So but actually what is this line? This line is nothing but it is behind VP. So here the behind VP is vertical here, that should be transformed into horizontal distance. So to do that, then from P you draw a horizontal projector which will comes to this end, because that is the end of this particular vertical plane, and from there you draw an angle of 45 degrees with respect to this vertical line. So what happens? This vertical distance is transformed into the horizontal distance. And where you have the front view, on that line you will going to get the side view. So you draw a vertical projector from here. And once you draw the horizontal projector from P dash, both these two will going to intersect at this point. You mark this point as P double dash. So this is how you will be able to analyze this problem, and then by using the scale you measure the distance from these two, from XY line to this small p. So this is how you will be able to analyze this. Now when you go to the final solution, so how to draw this by using the sketchbook. So to do that, first we are going to draw the XY line and X1Y1 line. And then you identify the planes. The identification of the planes is HP here, VP here and RPP here. Because we are rotating this like this, that is, this one should be like this, okay? Then this one will be like this. Like this. Once you do that, so what happens? HP will be aligned, RPP will be aligned, LPP will be aligned with LPP will be aligned with the vertical plane. Here it should be LPP, and this will be HP, and this will going to be VP. Then as we know that the distance with respect to the profile plane, you are not given any distance, so you take any at any distance you draw a vertical projector parallel to X1Y1 line. Then you measure the distance from XY line to 25 mm down, and you draw a horizontal projector, and then these two lines will going to intersect at this point. You mark this point as G dash. Then by using the compass, you measure the distance from origin at a radius of 45. You cut an arc. You cut an arc on this horizontal projector, and you mark this point as G double dash. Then by using the protractor, you measure an angle of 45 degree with respect to the horizontal adjacent to HP. Then you draw a vertical projector from G double dash to this 45 degree line, and again from this point you draw a horizontal projector. Both these two lines will going to intersect at this point. You mark this point as G, and you show this as any distance, and you draw a dimension here and show L is equal to question mark, because that is the distance with respect to VP, that is behind VP, has to be identified, has to be measured. Then by using this scale, when you measure the distance, you are going to get L will be equal to 37 mm. But the dimension what you got here is 37.42, which has been done by using the software, CAD software. So, and show the dimension of 25, and show the dimension of this as 45, and this angle as 45 degree. So, and mark this as XY, X1Y1. So, this is how you will be able to analyze this particular problem of the shortened distance in third quadrant. Thank you.